good day, geometry. We're moving on to chords today, and talking specifically about the properties of chords. We're kind of going to go through, the three main pieces: chords, secants, tangents. And today's objective is all about chords. And the four theorems that we have to talk about, two of them have to do with congruent chords, how to mathematically tell whether or not you have congruent chords. And the other two have to do with diameters and chords and the relationships that they mathematically have. So let's start with the congruent chords. Okay, we're going to draw a circle here. Ooh, that's a good looking circle. Okay. We're going to draw in two chords, one going like this, one going like that. Okay. And what do you think is the relationship between congruent chords and the minor arcs that they create? The congruent chords and the minor arcs that they create. Drew.
The arcs they create are congruent.
The arcs they create are going to be congruent as well. Okay? And we're going to mark these with a different congruency markers because one's an angle measure, right? Arcs are measured in degrees, whereas chords are measured in length. Okay? But congruent arcs are going to create congruent chords. So one way to tell whether or not chords are congruent, essentially this theorem says that congruent chords will create congruent arcs, and vice versa. Okay, if you have two congruent arcs, you know that the chords that create those arcs are congruent. So let's put in a couple points here, just so we can kind of. Here's A, B, and C, and D. We know that segment AB is congruent to segment CD because arc AB is congruent to arc CD. Okay? Those two things will go hand in hand. Congruent chords with congruent arcs and vice versa. The other way to tell whether or not you have congruent chords has to do with their distance from the center. So go ahead, theorem 10.4. Thank you. As I get further into it, my circle game just ramps up and up. My first one's better, you think? Well, maybe. And we're going to put the center in, okay, and two chords. Right? The other way to tell that two chords are congruent is if they are equidistant from the center. How do you know, or what needs to be, what are you measuring to say something is equidistant from the center? Because, like, you don't have to draw this part out here, but if we had a circle here with a center, I mean, if I ask you how far away is that chord from the center, are you going to measure, that distance, or that distance, or that distance? I mean, probably not the third one there, but when you say something is a distance from the center, what are you measuring? The closest. And how do you ensure that you're measuring the closest distance? Adam? It's perpendicular. Okay? So what we're measuring here is from the center, we're going to make a perpendicular segment to each chord. Okay? That ensures that you are measuring the closest distance. And if those two things are congruent, if these two segments are congruent, then you know you have congruent chords. Okay? If two chords are equidistant from the center, which is done by measuring those perpendicular segments, okay, then you know the chords are congruent. So congruent chords will create congruent arcs and vice versa. Okay, chords are congruent if they are equidistant from the center. Okay? Chords are congruent if they are equidistant from the center. All right? Questions on those two pieces? How to tell congruent chord. Joey, you have 2 questions?
I'm yawning.
Okay.
Which is correct.
Out of excitement?
I'm confused yawns. Wait for him to
Okay. Our next 2 theorems have to do with diameters. So again, we're going to draw a circle here. Thank you. Is that because
It looks like it.
looks like it's a good circle?
Don't make me. How do we know you didn't mean to draw me?
Chords don't have it. Or opals don't have chords.
They can't.
Okay. Let's say that we have a segment coming through here. We'll draw it like that. And let's say that we have another chord coming down like this. If we know that those 2 chords intersect at a right angle, and we know that these 2 pieces of that shorter chord are congruent, making the first chord a perpendicular bisector, right? This longer chord, because of what it does, is a perpendicular bisector. Think all the way back to Unit 5 for that. It bisects that second chord and it intersects it at a 90-degree angle. What do you suppose is true about that long chord, the one that does the perpendicular bisecting of that shorter chord? Yes.
It's it goes straight to the center.
Thus making it the diameter, exactly. Okay. If you have a chord that perpendicularly bisects another one, then that long chord, that first chord, we'll label it AB here. AB is the diameter. Okay. So, what does theorem 10.5 tell us? It tells us that the diameter of a circle will be the perpendicular bisector to another chord. Okay? Diameter of a circle will be the perpendicular bisector to another chord. All right? And it works vice versa also, right? Before I put that center dot there, what the information that we had was that the perpendicular pieces and the equal parts there. Because of that, we know that AB is the diameter of the circle. So that's another vice versa one also. Theorem 10.6 is very similar to Theorem 10.5. So we're going to start by drawing a circle. This time, we're going to know that we have the diameter. So I'm going to draw the diameter in there, roughly. That's a poorly drawn diameter. You can do better than that. It's not, you're right.
It looks like a chord.
When you freehand and you use the phrase looks like, that's a little bit different because freehand isn't always accurate. I will grant you that piece there. Okay? So it doesn't look like a diameter, but because I marked it to center, I'm telling you it is, that it is. Okay? So if we know that that's a diameter, and we know that we've got another chord coming through here, okay? Not only do we know that we've got this right angle here, we also know that these 2 sections of the shorter chord are congruent, which then also tells us what? And this kind of goes and connects back to Theorem 10.3 a little bit. Well, The two arcs are congruent as well. Okay, so the difference between theorem 10.5 and 10.6 is really, in theorem 10.5, we're concluding the diameter because of the perpendicular bisector relationship here. In theorem 10.6, we're given the diameter, and because we already know it's a diameter, we can then go, not only do we have that perpendicular bisector part there, go one step further and say the arcs are congruent as well. Okay? Who knew there'd be so much fun stuff with chords, right? So in words, theorem 10.6, you can say that the diameter of a circle will bisect a chord and its associated arc. Right? The arc that was created, we'll call this CD here. The arc that was created, arc CD, was bisected by the diameter as well. So the diameter bisected both the chord and the associated arc. Okay? Questions on those four? Comments, concerns, complaints, comments, congratulations, criticisms. Looks like there are none. All right. Let's go. Answer each question. Identify which of the above theorems you referenced. The first one, if the measure of arc AB is 110, so by arc AB, we're referring to the shortest distance from A to B there, right? We know it's a minor arc, 2 letters there, 110. What is the measure of arc BC? So what we know is the measure of arc AB. We're trying to find the measure of arc BC. What do we got? Drake? 110. And mathematically, Drake, how can you defend that? Which of the above pictures looks a lot like that one? Theorem 10.3, right? And you don't have to write out all the words for the theorem. Theorem 10.3 is perfectly fine. The whole point is basically kind of relating the pictures from above down to what we have here. Then it says, the second piece here, if the measure of arc AC is 150, so here's what we're given, okay? If this is 150, what is the measure of arc AB? In green is what we're given, in red is what we want to find out. What do you think? Blake?
105.
How'd you get that?
360 minus 150.
Okay, so 360 minus 150, right, is 210. And 210 represents this whole section here. Because if from A to C is 150, that means the major arc going the other way, ABC, has to equal 210. Because total there has to be 360 degrees in the circle. Right? That arc addition postulate tells us that 150 plus 210 would have to equal the whole thing. Going one step further, we know that B is kind of the midpoints of that arc, right? Because if we have got those congruent chords, that means that these two pieces are congruent. And so if the whole thing, ABC, is 210, we're dividing that into two congruent segments. 210 divided by 2 would be 105, as Blake said. Okay? It's going to be very important in your test to remember that a circle has 360 degrees. Seems simple, but for those of you that were not quite sure where to go from here, just knowing that AC is 150, we wanted that part there, the key was getting the rest of it. And there's at least 2 questions on your test that I can remember off the top of my head where you just need to remember, oh, a circle has 360 degrees. I'm being told this, the rest of it is whatever, right? Okay. Questions on that one? Okay. Second one. Oh boy. What do we got? BD is marked as the diameter. because it passes through center A. I don't care if you think the diameter is bad. I don't care if you think the diameter is bad.
That's great.
But BAD.
Or so bad, yeah, see, that
No.
was good.
That's
Usually that gets quite a rousing response. I don't know.
That's such a good diameter. Why would you call it that?
It's
Yeah.
usually it really
Because it looks like.
gets the crowd going.
Yeah, we know it's diameter.
Yeah. Okay. So anyway, what does this tell us here? What else do we know? We're given the right angle. We're given its diameter. Seppa?
Since according to 10.6, the arcs would be congruent. So if you set up an equation, x would equal 8. So therefore, CD would be 72.
Look at you. You're just going right through it. Yes, exactly right. Because this is the diameter, we know it bisects not only this chord, it's not marked, okay? But we know it does. It also bisects the arc. So as Seppa said, we can set up the equation. These two sections being congruent, 9x will equal 80 minus x. We can add x to both sides to get 10x equals 80, which means that x equals 8. Okay? And if we're looking for arc CD, 9 times 8 equals 72 degrees. Okay? And Seb said he got that from theorem 10.6. Questions on that? Okay. Now it says, what is arc CBE? So we're using the same information as we had in the first question there. Now we're looking for arc CBE. Joey.
Arc CVE would be 216.
And how do you get that?
360 minus 72 minus 72.
And where's the second 72 come from?
On the other side.
Oh, yes, of course. If these two arcs are congruent, it means that arc DE is also 72, which means that this part that we know is a total of 144 degrees. Right? Arc CE is a total of 144 because it's bisected. We know what one section is. The other section will be 72 as well. And then, how many degrees are in a circle? 360. 360 minus 144 gives us 216 degrees. Okay? All right. Oh, weird. Next one. What do we have? What are we trying to find? We are looking for CU.
Later.
Nice.
So funny, Blake. Thank you.
What do we know about this diagram? What do we conclude?
There's 5 of them.
5 of what?
What in the world? There were 7 letters of last.
Oh, there are 7 letters.
8.
Okay. 8 letters.
You see it.
Okay. I only see 7. Oh, that's variable. Gotcha. Drake. Which says what? Okay, and we're also told the chords are congruent, right? Because QR and ST are both marked as 16. Actually, we don't know that CU and CB would be congruent without having the chords marked as congruent, right? It's not, you have to know one to know the other. If you know these segments are congruent here, you know the chords are congruent. Or if you know that the chords are congruent, you then know that those segments are as well. Because we're given the congruent chords, that's what allows us to conclude that 2x is equal to 5x minus 9. All right? The fact that the chords are marked is what allows us to conclude that CU is congruent to CV. do a little bit of algebra. Move our 5x over. Negative 3x equals negative 9. X equals 3, which makes CU equal to 6. The one below this. What is the radius of circle C? What is the radius
Joe's got it.
of circle C?
Figurine has it.
I got first.
Figurine's in high.
Bubbles!
10.
How do you know that?
Answer.
Because it just is.
Why?
Pythagorean theorem.
What allows you to say that?
Because I just said it.
But what did you set up? What did you? How do you know you? I don't see any triangles anywhere in here.
Because
Make your own.
Make your own.
Yes.
How?
Connect the middle part
Point C.
to part T.
Okay. Sounds like a party.
Wow.
So we have to actually draw in our own radius here, right? There's not a radius drawn for us. We can connect that point from C to any point on the circle. We chose T for the pun, obviously, right? So now we have triangle CVT. Obviously, CVT is a right angle. We've already solved for CV. I'm going to kind of draw it over to the side here. We've got CVT here. We know the right angle. We know this is 6. But in order to use the Figurine Theorem, we have to have 2 of the 3 sides. Where is another side coming from? Well, how do you know we can divide the 16 to 8? It is? How do you know that?
Oh my.
It's
gonna look
The
like
what?
it.
Is every right angle a perpendicular bisector?
Yeah.
Really?
No.
If I've got a circle with a chord coming through like this, because this is not the diameter coming through here, right? But if I have something coming from the center, and are we guaranteed that that is going to bisect that chord?
Yes.
Because it's coming from the middle. If we extended CV, it would be the radius coming down, right? That is enough to conclude that it's bisecting that chord. Okay? That is enough to conclude it's bisecting the chord. Therefore, we get this section to be 8, as Will said, and as Bubbles brilliantly concluded on his own merit, the 3, 4, 5 triangle would give us 10.
Yeah. Yeah, bubbles.
Okay? Yes. Hey, Drake's got an actual mathematical thing to say. Oh, I'll have to go back. I don't remember exactly where I wrote it. You have to check the video. Like and subscribe. Alright? No homework for tomorrow, although you will have a quiz when you enter class on CO61. Just preface that. Have a nice night, folks.
Like and subscribe.